Let's begin by laying down a DOPNet and a DOP import.
I always like coloring my DOPNets blue, just so it's easier for me to find them. The actual DOPNets I colored dark blue and the other one's a bit lighter. So let's do it like that. On the DOP import node, let's set the import style to fetch pack geometry from DOP network because we have pack geometry right there. And what we can do is we can just grab the DOPNet and drag it into the DOP network. We'll have to set the object mask in a moment. Let's also drop down a box. Call it ground_object, so it's easy for us to identify. And let's also color it blue so that we know it belongs with the DOP network. Let's make the size 100 by 100, so that fits comfortably underneath all of our buildings. And we want the top of the box, so the top face, to be set at 0. So what we can do is we can take the size of this channel, paste it in, paste copied relative references, half it, either divided by 2 or times 0.5, whichever you prefer, and lower it, so a minus in front. So this is what you should have as an expression in there, or you can have it like this. Doesn't matter, same thing. Now what we should see is that our buildings are somewhat floating above, which is the case. Let's leave it there. Now inside our DOP network, let's go and construct that. For our buildings and our ground, we want two different objects. We want an RBD packed object. This will be our buildings, and we want an RBD object. And this is going to be our ground object. On the RBD object, let's find the subpath and set it to our ground object. Right there. Accept. And on this, let's find out buildings on the RBD packed object. And that should be at the top because we've capitalized the out. There we go. Let's merge them together. Now we're going to need gravity. So let's put down a gravity force and wire that up. And we're going to need a multi-solver. Because what we need is we're going to have a particle solver, a pop solver, and we're going to have a bullet solver. So let's put them both down as well. So let's merge these two solvers together, put on a merge node, wire them in. And we can stick the merge one into the left input of the multi-solver, the objects to be processed. So that's the collision object for the floor and our building bounding boxes. And here in the second input, we can wire solvers. So let's merge that in there and wire this up to the gravity node. So now we can see that our buildings and our floor are being pulled in correctly. All right, instead of an RBD object for the floor, we actually need a static object because if we're going to simulate this, it's going to fall down as well. We don't want that. So let's just remove that, drop down a static object instead, merge that back in, and let's just switch those inputs back. So I want static object 1 to be the first input. Let's find that, find the subpath again to the floor, ground object, and accept. So now if we hit play, we should see that it doesn't actually move. It's not affected by the gravity, which is correct, and our buildings obviously are. Let's have a look at our RBD packed object. So we want this set to create active objects. That should already be the case. Let's have a look at the bullet data. Let's set the timeline back to 1 and visualize the guide geometry. We can see that it's there, but it seems to be inside of our bounding boxes. So let's drag this window down a bit, make it bigger, and we should find a shrink setting here. Shrink collision geometry. We don't really want to do that. So if we turn that off, the blue bounding box will be the exact same size as the buildings themselves, which is what we want, because if we're going to shrink them a little bit, they might actually slightly intersect, and we want to avoid that. So both the bullet solver and the pop solver shouldn't need any settings changed, but we will need to create a force that attracts the buildings to the center. So we're going to put down a pop-vop, and we're going to wire the pop-vop into the post-solve. Now depending on your version of Houdini, you might have to go into the inputs tab on the pop-vop and set the input 1 to whatever input you're using on SOP level, but in 15 or up you shouldn't have to do that. Just double check that after you've constructed the force inside the pop-vop, if nothing works, that might be a solution for you depending on your version. Let's jump inside. Now this will be really simple. All we need is a constant set to vector and a subtract. And what we're going to do is we're going to set this to a vector, leave it at 0 because that's our center vector or our center position, and we're going to subtract from our center the current position for each packed primitive, right? Because they're all packed. That's why a pop solver works on these buildings. And then we're going to put the difference into the force. Now let's jump back up And let's see what happens if we play our simulation. Let's just double take back and play. So they do drop down and they're moving, but they're not actually moving to the center. Let's go into our RBD packed object and look at the physical tab. So we don't really need mass. We are not actually doing a proper simulation. We just want them to move to the center regardless of their size or weight or anything like that. So let's turn that off. So now that we have turned compute mass off, let's check the other settings. We want mass to be left at 1, right? Every building has a mass of 1. Let's leave it there. And we want to set the other values to 0. So rotational stiffness, if you set that to 0, these buildings will no longer rotate around their y-axis. They'll just stay stiff. And we don't want them to bounce, and we also don't want them to have friction. We just want them to move to the center, collide with each other, and form a cluster. Now let's see what happens if we reset. Make sure output is visualized. Reset the simulation by double-clicking reset to first frame, and press play. Now we can see they're all moving to the center. Bit aggressive, but they'll be pulled down. Let's just let it run for a few hundred frames. And let's set that to 200. And there we go. We have our building cluster. Now, of course, we still need to import it in our DOP import. So let's have a look. It's RBD packed object. Let's just double click that. Control C, copy it. Go up one level, visualize our DOP import. Make sure we hide other objects so that we know what we're looking at. And in our object mask, paste that. So instead of the floor and everything, we've just got the buildings. That's what we want. Let's go ahead and create a few of these in the next clip.